Hope my voice is audible and are you able to see my screen? Please give me a confirmation. Okay. Okay, let's get started. So today Ganesh is not going to be available because of his project work. We too will continue discussing about bitwise operators. So in our extra days class, I have just introduced about the bitwise operators, right? So when you say bitwise operators, these bitwise operators they are not specific to Java programming language, right? Every programming language is going to what we can do some manipulations by using bitwise operators in each and every programming language. It's not specific to Java. Right? So we will understand this bitwise operation or operators with respect to the Java programming language. How the memory allocation is happening internally, how the numbers are getting converted to binary numbers, and how the values are getting evaluated, right? So these are the bitwise operators like bitwise or, bitwise and bitwise XOR, and we have also have bitwise complement, left shift operator, right shift operator, and triple right shift operator. So we can also call it as unsigned right shift operator. We will discuss the remaining things which is left to be discussed. Today we will discuss about this, and every discussion happened with respect to the truth table. So I don't think I need to explain it once again. This is the truth table for OR operator. This is the truth table for AND operator, right? And for any two inputs, the output is going to be calculated according to the truth table of each and every operator, each and every bitwise operator. If it is AND, that you want to do AND operation between two operators or between two inputs, right? If you find like at least if you find at least find all the two values are one, right, the output is going to be one. If at least one value is zero, the output is going to be zero. The OR operator is just opposite. If at least one value is one, the output is going to be one, right? And we have XO or XOR operator. It means for same values the output is zero, for different values output is one. And we have taken few examples on top of these operators. Now we will understand about bitwise complement, left shift operator, right shift operator, and unsigned right shift. First we will go with left shift operator. We will complete the shift operators, then we will talk about bitwise complement operator for a better understanding. So let me open a new page. Right. Okay. Now we will discuss about bitwise left shift operator. Bitwise operators. Left shift operator. So left shift operator is represented by an angular bracket, we can say, or we can also say it as the lesser than symbol, two lesser than symbol. The combination of two lesser than symbols, when it is pointing towards left, isn't it? It's just like an arrow that is pointing towards left. So combinedly, this is called as a left shift operator. Right, two arrow keys pointing towards left is called as what? Left shift operator. This is the typical symbol for left shift operator. Left shift operator. So let us understand this. So when I say for any given number, if I do left shift, for any given number, for any given value. For example, let us say that, let's take a small example like a equal to 5. If I have a equal to 5, and if I do a left shift 1, a equal to 5, and I just want to do what? 5 left shift 1. Right, what the output is going to be. First let us see the output that is getting displayed by using Java program. And on top of this output, we will analyze, we will evaluate it from our end. The same question I am taking here. System dot out dot println. So instead of a equal to 5, I can directly I can directly substitute 5 left shift 1. If I do this, so the output is 10. If I do 5 left shift 1, right, the output is 10. Now the question is, why the output is 10? What is happening internally? That understanding is required. Let me copy the same program and let me use this paint screen. So this is what the program is, right? So we have done, we have used the number 5. With the number 5, we are left shifting this number with 1. Very simple. I have just used a left shift operator in between, right? So let us say if I am using 5 plus 1, it is going to be 6. We know that because we know how to evaluate the mathematical operation with the plus symbol. If I do minus, 5 minus 1 is going to be 4, right? If I do 5 left shift 1, it means that internally some kind of mathematical operation is being performed and I am getting the output as 10. We need to understand what kind of mathematical operation is being performed internally, right? When I do this, the output is what? 10. The output is 10. Why the output is 10? That understanding is required. Let us analyze that. Okay. Firstly, let us think like a beginner. Whenever you prepare a Java program, right? Whenever you prepare a Java program, it is mandatory you can address this, or you can call this as source code. What do you call it as? The program prepared by a developer is always called as, or it can always be represented as a source code. And the source code need to be saved in a specific format. The format is very simple. Just use .java extension. What is it? .java extension. And what should be the name of the file? It should be same as the class name. Here the name of the class is bitwise operators. You can give any name, but the name is, its name is very meaningful, isn't it? That's why I have given it bitwise operators.java. This is called a source code. Every source code needs a compilation, because just give me a moment. Give me a moment. Okay. So every source code needs a compilation. So compiler will come into picture to check. Its duty is to check if the source code has any errors or not. It will ensure that the source code is error free. So compiler will come into picture. Compiler. Now this bitwise operators.java will be taken inside the compiler, right? Compiler will convert this .java bitwise operators.java file to .class file. What happens? The .java file will gets converted to what? It gets converted to .class file. Operators.class. So conversion is completed. After the conversion, this .class file will be loaded into the JVM for execution purpose. These are the stages that happens internally, which we are not aware of actually. So we don't see this. Internally these things are happening, but we as a developer, we are not aware of this. Okay. So the JVM comes into picture. JVM is also called as what? Java virtual machine. The job of the Java virtual machine is to execute the code. Java virtual machine, right? It takes this, this .class file will be taken inside the, JVM is going to take this .class file for the execution purpose. So this will be loaded inside the JVM. right? As soon as it is loaded, the JVM is going to create a thread. We have seen this yesterday. A thread will be created. Thread is not like an English dictionary thread. Thread is called as the control. We can say that a control. This control will try to find the main method. This control is going to fetch the main method, or it is going to search for the main method. Yes, there is a main method. Main method is over here, isn't it? Okay, its duty is to find the main method and execute all the instructions that is present inside the main method. So main method is found. Okay, in the main method we have only one instruction. What is it? System.out.println 5 left shift 1. So now what happens? Now what happens? The control, the thread, I mean the particular thread is going to point here. The control is transferred here. Very simple. This thread will try to fetch the main method. Yes, it has found the main method, and it will execute all the instructions inside the main method. It has found only one instruction inside the main method. So this instruction needs to be executed, right? So it will convert the 5 will be converted to the equivalent binary number. 5 is a decimal number. It has to get converted to what? The equivalent binary number. Internally, memory, there will be a memory. Memory will be stored in the form of binary numbers. We have seen this yesterday. So a memory storage will be created, right? The storage will be split into what? 8 bits. Eight spaces. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. Now see, now interesting things will happen now. Okay, it has been split into 8 bits. So what is the equivalent value of 5? I mean 5 is equivalent to a particular binary number, which I can write it like, let me use a red color. This is how I can convert 5 to the binary number. Do you agree this? Right? 5 can be converted to this binary number. Do you agree? Just type as in the chat box if you agree. Right? This is the binary representation of 5. Are you with me? Are you agreeing this? Okay. Okay. This is how 5 is converted, right? And now you see, we are saying 5 left shift of 1. So internally what will happen is, another memory block of same size will be created. Try to focus here. Another memory block of same size will be created, right? So here we are using, just observe the symbol. Just I am specifying the symbol. This particular left shift operator, the job of the left shift operator is to move each and every bit to one position towards the left. What does it mean? To take this, if you consider this memory, right, each and every bit will be moved to one position left. So each and every bit will be moved to one position left. And the question comes now. What is the question? Okay, what happens to this bit? The remaining last bit 0 is there, right? 0 has no place to be hold, or there are no no fillers. 0 can't be filled because there is no space for this 0 to be filled, right? So this 0 will disappear. This 0 will disappear. There is no space for this 0 to be filled, so the 0 will disappear, right? So this each and every bit will occupy its new position. So this 1 is going to occupy this place, 0, and so on. This is how the position gets occupied, and the last 0, it has no place to be filled or to be held, so it will be disappeared. What about this remaining space? What about this void space? This void space will be filled with 0. Let me take another color. This void space will be filled with 0. This is what, these are the things that happens internally when you try to use the left shift operator. Hope making sense, right? If I say 5 left shift 1, one bit, each and every bit will be shifted to one position to its left. As simple as that. And the bit or on the value that has no position to be hold or no position to be place, okay, this value is going to disappear, right? And the void that is creating here, the empty space that is getting created here will be filled with 0. Right? Now you convert this. Now this number will be converted to the equivalent decimal number. Right? What is equivalent decimal number for this particular memory, for this particular binary number? Very simple. This is 2 to the power of 0, this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. Everything is going to be 0. Consider this only values of one bit position. So 2 to the power of 3 is going to be what? 8 plus and 2 to the power of 1. Consider this. We are going to consider this too, because remaining things are 0. You consider only 1. When only the position values of first, one's bit. So 2 to the power of 3 plus 2 to the power of 1. 2 to the power of 1 is 2. So 8 plus 2 is going to be what? Right? The output is what? We got output as 10. Right? So this is what the JVM is doing. When you do left shift to 1, right, the output is 10. So this is how the internal things are happening. By looking at this, I can come to one conclusion. What conclusion I can come? If you shift a number, if you left shift a number, right, if you left shift any number to 1, right, the number is getting doubled. Can I come to the conclusion? When I say phi left shift of 1, when I say phi left shift of 1, the number is becoming double. The answer is becoming double, isn't it? Answer is becoming phi into 2, which is 10. Okay, this case is valid because this is what we are it is visibly seen here. That's why it is valid, right? But if I do the same thing, if I do the same thing with the number 2, if I left shift a number with 2, the number should be what? Now the number should be 20, right? Let us see if I do the same thing with the number 2. See, number is 20. It is doubling its size. If I do it 1, it is doubling it. Number is becoming the double of the actual number. If I do it with 2, all right, firstly it is getting converted into 5 into 2. Then the answer is getting evaluated again into 2. Is 20. But if I do it with 3, it should be 40, I guess. 40. It keeps doubling. Right? If you do the same thing, if you trace this by using this concept, by using this tracing method, you will get the same output. And why this is happening? Because each and every bit is getting shifted to the one position towards its left. Right? If it is getting shifted to one position towards its left, the value is getting multiplied to the 2 types of its original value. That is what happening. So I can come to a conclusion saying that the conclusion is very simple. So the left shift operator is actually doubling the number from its original size. Nice. Example, if you do phi left shift of 1, phi is getting doubled. So phi into 2, I can say. If I do phi left shift of 2, I can say phi into 2 to the power of 2, or I can say phi into 2 first, then the answer is again getting evaluated or again getting multiplied with 2. So the output is what? 20. When I do phi left shift, what did I do here? It's not left shift. Left shift. Phi left shift of 3. Right? The output is going to be phi into 2, and the whole set will get multiplied with 2 again, and again this whole set is going to get multiplied with 2. As simple as that. To take any number, and so we can like represent this with a simple formula like 5 into 2 to the power of n. So where n is number that is represented after the left shift operator. Right? Making sense? Right? If I do 4, it means 5 into 2 to the power of 4. So 16 pies, or we are getting this answer is 180. Right? Same goes on. So this is all about the left shift operator. Okay. And again, I know that the questions, so many questions would be running in top of your mind. Why these things are really necessary. So you will understand about this usage more in the future classes, because these fundamentals are going to help us out in developing or in solving the data structures and algorithms problems. You will find many areas where this topic is highly used. Right? Please bear with me. So this is part of this understanding is very important to understand the internal structure of any memory, any computer memory, not only for Java. These concepts are useful for all the programming languages. Right? Let's continue. So we have completed the left shift operator. Right? Now the next thing is we will discuss about the right shift operator. Right shift operator is going to behave a little weirdly. Right shift operator. It is one of the bitwise operators. The symbol for the right shift operator is what? Just opposite to the left shift operator. So it is going to be like this. Two angular brackets are two greater than symbols. Two greater than symbols. Two sequential greater than symbols. We call it as what? Right shift operator or arithmetic right shift operator, or we can also call it as signed right shift operator. So this is incorporated with so many names. Why these many names, we will understand it. So these are the 3 names, valid names that you can define about the right shift operator. You can also call it as arithmetic right shift or signed right shift. Signed right shift operator. Right? Same example we will take. When I say 5 right shift, 5 right shift. Let us this is the right shift, right? 5 right shift 1. Let us do this in the program. Previously we have used a left shift, but what will happen if we use the right shift? I'm doing the opposite. Previously left shift means doubling the number. The answer we get is 10. Why it is 10? We got to know from the tracing part. Now we are going to use the different operator, which is right shift operator. When I do this, the answer is going to be different. Answer is 2. Why it is 2? We'll understand it. Are you able to see? Answer is 2. Why it is 2? We'll understand. We will understand it. Right? Let me copy and paste the same program. Every time whenever a program is prepared, try to think yourself or try to think like a beginner. How does a beginner think? Very simple. Prepare a program, right? Just imagine the internal things, as simple as that, because you will not forget. For the small program or for the big program, you're developing any sort of big applications, the internal things are common. The internal things are going to be same always. Saving the file, compiling, execution. These things you should not forget. So now again the same things. It may be looking a little boring to repeat these things over and over again, but trust me, these things are really important. Save it as .java extension. Get the compiler, keep the compiler in place. Right? What compiler does? Its job is to ensure that the program is out of errors. Compiler is going to accept the .java file, which is also called as a source file. Right? It's going to accept this, and it will produce .class file. If there are no errors, the equivalent .class file will be produced. The name is going to be same. The class name is going to remain same, but the extension is going to be changed from .java to .class. As simple as that. Very simple. Very rudimentary. You don't need to worry much about this. Operators.class. After this, JVM comes into picture. The main purpose of JVM is to execute the program. JVM. Java virtual machine. And JVM will take in what? It is going to take in the .class file. The .class file will be loaded inside the JVM. You can tell in many ways. The .class file will be loaded inside the JVM. As soon as .class file is loaded, JVM is going to create a main thread. The job of the main thread is to find, it will fetch for the main method, right? It's going to fetch for what? It is going to fetch for the main method. Obviously, the main method is existed. Main method is over here, and it will execute each and every instructions present inside the main method. This is the instruction. The instruction says 5 right shift 1. So same thing will happen internally. This time, let me write like this. Memory. I am assuming 1 byte of memory. That's why internally it is going to take what? 8 bits. 1 byte is equivalent to how many bits? 8 bits. Collection of 8 bits. How the 5 gets represented in? They want to represent 5 into the binary number, right? This is how the 5 gets represented as a binary number, 101. So everything remains to be 0. Right? Now, let me take a copy of this. Okay. So 5 is getting represented like what? 101 0 0 0 0 0. Right? But here I am saying right shift. 5 right shift 1. Previously it was left shift. So the shifting was happened in such a way that each and every bit is positioned or is placed towards the, by skipping the 1 bit, and it is placed towards the next bit. Each and every bit is moved to the left, towards the left side. So now the things are going to be reversed completely, since it is a right shift operator, isn't it? Each and every bit is going to be placed 1 bit towards its right, 1 position towards its right. Right? If this is happening, this particular one will be disappeared, because there is no holder for this, no position, or we can call it as no memory allocation. This will be moved out of the box. This will be disappeared. One will be disappeared. No holder for one. The remaining things will be intact. So remaining things are going to be placed just like that. And there will be a void created here. So listen here. There is a void. Void is nothing but a space will be created. Right? We need to fill this space. Now the question is, on what basis this place will be filled? What are the things that we need to consider to fill this place? Very simple. right? MSB, yesterday we were talking about what MSB. If you remember MSB, most significant bit. The leftmost bit is called as MSB, the most significant bit, right? When you find the whatever the MSB value that you are finding it in the actual number, you fill the void, you fill the gap with the same number. As simple as that. In this case, the MSB is what? 0, right? So fill this void or fill this space with 0, right? I can simply say fill the void or space with the value of MSB from the actual number. So these are the values. Now these are the final values that we have ensured by using the right shift operator, complete right shift operator. Right now, the equivalent decimal representation of this value is going to be what? Right, 2 to the power of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on. Keep everything. Keep this. Keep this. Include this because it is a positional value of 1's bit, right? So 2 to the power of 1 is going to be what? 2 to the power of 1 is going to be 2. So the answer should be what? The answer should be 2. Are we finding the same answer here? 2. Output is 2. Why output is 2? Now we got to know why the output is 2. Each and every bit is getting shifted to one position towards its right, and the void space is being filled with the most significant bit, right? And the value, the rightmost value will not have any place or will not have any memory allocated, right? So this is going to get disappear, right? So when you say phi right shift 1, right, the answer is going to be what? 2. Why 2? Because of this internal operation, right? This is one of the conclusions. But the second conclusion is very important. First conclusion, second conclusion is very important, right? So let us do one more thing. If I do right shift for 2 times, for 1 time the answer is very straightforward. The answer is 2. If I do the right shift operator, if I use the right shift operator with the number 2, the answer is 1. So in this case, what is happening? There is a pattern, there is an algorithm that is hiding behind this particular right shift operation. What is the pattern is, in the left shift operator, if you use left shift operator, every time it is getting multiplied by 2. But if you do right shift operator, every time it is getting divided by 2 plus that, but it is considering the floor value. What is the floor value? If I say 5 divided by 2, floor value for 5 is what? 2. The quotient value. 2 to 4, right? 2 is the quotient value, right? The quotient value is going to be the floor value. The answer is 2. Right? And again, if I do the right shift for the second time, the answer is going to be 1 because floor value for 2 is 1. 2 divided by 2 is 1. So the conclusion is, whenever the right shift operator is used for a particular number, the resultant answer is the division of 2. The resultant answer is a division of 2 floor value. For the left shift, it is the multiplication of 2. For the right shift, is a division of 2. So this is an algorithm hidden inside, then deeply inside, right? So this is the conclusion. Now the pretty important question is going to be like, sometimes there are high chances that you may get what? You will have to find the you will have to use this right shift operators for negative numbers. So when I say negative number, 5 is a positive number, right? When I say negative number, just use a negative number, minus 5. If I do this, so we get minus 2. In this case, we are getting minus 2, right? How the things are happening for a negative number? For the positive number, the answer is 1, but when I do the right shift operator with a negative number, right, the answer that we are getting is what? The answer that we are getting is 2. So let us do it for the number 1. So we are getting answer as minus 3. Why minus 3? We will analyze it now. Okay. Why minus 3? We will analyze it. We got to know the answer, the value for the positive number. For the positive number, there is no confusion, right? Because you can perform this analysis. You can do this tracing method. This is how it can be traced. But for a negative number, this tracing could go wrong. So you need to follow a different tracing algorithm, which I am going to explain now. So let me use this space. This is for same right shift operator for a negative number. It's right shift operator for a negative. So in our example, you are going to take the same example. Right? Example is like minus 5 right shift of 1. So we know the answer. So after evaluating, the answer is minus 3. But the question is, how did we end up to get minus 3? So this is the question. Now I will be answering it. Right? Same thing. Right? Let us create memory spaces. For minus 5, okay, 8 spaces are there, isn't it? Okay. First, let us find the binary equivalent of positive 5. For positive 5, the binary equivalent is what? 1 0 1 0 0 0 0 0. Right? And to find the negative equivalent for minus 5, what we will have to do? If you remember yesterday, we need to find what? We need to find the 2's complement. We need to find the 2's complement in order to find the negative of minus 5. Right? To find 2's complement, first of all, we need to find 1's complement. Isn't it? We need to find 1's complement. Then after finding 1's complement, by just adding 1, we will be getting the 2's complement of. Isn't it? So what is the equivalent 1's complement of this particular number? Just flip the numbers. If it is 0 1 1 1 1 1 0 1 0, this 1's complement. We will just flip the numbers. If it is 0, replace the 0 with 1. If it is 1, replace the 1 with 0. Right? And the 2's complement is going to be add 1 on top of 1's complement. Just simply add 1. Right? The output is going to be 1 1 0 1 1 1 1 1. Isn't it? This is the value. This is the value that we got. Right? Now our job is to find out. Now we will have to do the actual shifting. We have to perform the actual right shifting. Right? For the right shifting, so let us imagine that these numbers are inside the boxes. We take the boxes. Totally there are 8 boxes. So now you perform the actual right shift to 1. So this number will be disappeared. Right? So let me create 8 spaces. Right? This number is going to disappear. This number is going to take this position 1. Right? Likewise 0 1 1 1 1 1. Right? So this number is void. Void means there is a space created here. So I have already mentioned that the most significant bit is going to occupy this position. In this case, the most significant bit is what? 1. So 1 will be placed. So let me write it in 3. So in this case, MSB is going to occupy, MSB is going to be filled in void. Void is nothing but the space that is getting created when you do what? When you do right shift. Right now the question is, I cannot convert this. I cannot convert this number directly. I cannot use this. Cannot do the direct conversion because it is going to become such a big number. Again, I need to undo the 2's complement. Previously, I have done the 2's complement. Very simple, guys. Right? For a negative number, first do 2's complement. After doing 2's complement, our duty is to do the shifting, actual shifting. We need to perform the actual right shifting. Right? First do 2's complement, then do shifting, then undo the 2's complement. Undo 2's complement. How do you undo 2's complement? Very simple. First minus 1, first do minus 1, then flip the numbers. In this case, first let me do minus 1. Right? So answer is going to be 0, 0, 1, 1, 1, 1, 1, 1. Right? Minus 1 is done. Now flip the numbers. So this is undoing 2's complement. First do the minus 1, then flip the numbers. Flipping the numbers means very simple. Just if it is 0, replace it with 1, 1, 0, 0, 0, 0, 0, 0. Now what is the decimal equivalent of this number? 2 to the power of 0, 2 to the power of 1. Right? So these things won't be considered because everything is 0, isn't it? So the answer is going to be what? 3. Right? Add a negative sign to it. Why negative sign? Because MSB is what? MSB is 1. Add a negative sign. So answer is what? Answer is minus 3. What answer we got over here? Minus 3. Very simple. There is nothing to worry about here. When you do a right shift operator with a negative number, right? With negative numbers, you always have to bring in what? Bring in the 2's complement. Right? First you convert the number. First you actually convert the decimal number to the equivalent binary number. Right? Since it is a negative number, you will do what? You will perform 2's complement. After performing 2's complement, you will perform the actual shifting, actual right shifting to 1th position. Why 1th position? Because the question is right shift to 1. That's why it gets right shifted to 1th position. After right shifting to 1th position, right? It's our duty to undo the 2's complement. Undo the 2's complement and do the flipping, and you will get an answer. Just add a negative sign to it. Right? That is what we got here. Very simple. That's why we are getting it as negative minus 3. If you want to any additional proof, you do the same thing. If you do this, you work out this. You do this. You try to calculate this tomorrow. You will be able to find it. Right? When I do this, if I try to run this program by shifting it 2 times, we are getting minus 2. Why minus 2? You do that. Tomorrow you try to find it out. Why minus 2? The same logic. Right? This is your part. You do this tomorrow, you will get to know why minus 2. Right? This is all about what dealing with a negative number in right shift operator. But you might be getting a question. Do we have anything like this? Do we have to do anything like with negative numbers for the left shift operator? So left shift operator is, since it is unsigned, since we are not going to consider sign, so you do not have to do these things in the left shift operator. Only in the right shift operator, these things are allowed. What things are allowed is dealing with the negative numbers. Right? That's why it said right shift operator for a negative number. That's why here in the question itself, I already mentioned that right shift operator can also be called as a signed right shift operator. So sign is very important. They will give priority to the signature, to the sign. That is not the case with left shift operator. Right? That's why here we are bringing in the concept of most significant bit, because the leftmost part is going to get void. The space is created in the leftmost part. That is not the same case with the what in the right shift in the left shift operator. In the left, if you talk about left shift operator, right? No space is getting created in the left, right? Numbers are getting just separate, but no space is getting created. But here, if you look at it, the space is getting created in the leftmost part. Right? That's why we are bringing in the concept of MSBs most significantly. When you bring in the concept of MSBs, as we have already discussed yesterday, what? So we are going to talk about the negative numbers and the positive numbers. That's why this is also called as what? Arithmetic right shift or signed right shift. The signs are coming into the picture, right? I hope this conclusion is making more sense. Now let us discuss about one more operator, the triple right shift operator.